Hi guys. So what we're going to look at today is a little bit more factoring and then a couple more things about quadratics that we didn't look at the first day. So some of this is going to be reviewed from Algebra 1. Some of it is going to be a little bit newer or just a little bit expanded on. But again, still a lot of Algebra 1 review kind of overlapped in here. So the biggest thing we're going to focus on today is factoring. Now we're going to look at factoring not just quadratics, but we're going to look at factoring some polynomials as well. So you may see some new things coming up with factoring, but the process is going to be very similar. So in general, whenever we factor, there's a couple steps we want to consider. The first thing we always want to do, no matter what, we always want to start with the GCF. And this is really important for a lot of reasons. One, if we don't take the GCF, we may not notice that we can factor using something like a difference of squares. So we have to take it first. Two, sometimes the GCF is all we can do. And three, the other reason we need the GCF is a lot of times our question won't be factored completely if we don't take the GCF from the start. So after we've taken the GCF, where we go from there really depends on how many terms we have. So if there's only two terms that we're factoring, there are two things we want to look for. One of those is a difference of squares, which we saw last class. So a difference of squares is something in the form of a squared minus b squared. So a squared minus b squared is going to factor into the square root plus the square root and the square root minus the square root. And that's what we saw last class. This is one of the easiest ones to factor, but sometimes we may not recognize it. So that's why it's really important for us to be comfortable here so that we can recognize this one. Now, the another one that's new for you guys is whether if we have two terms and we know the cube root of both of those terms. Okay, so cube root. So let's think of some perfect cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. So those are some of the numbers that you may see coming up. So what we'll do there, it's a little bit harder because it's a little bit of a longer formula, but we'll start with, let's say I have something in the form of a cubed plus b cubed. Well, the way that factors is not how you might think it might factor. A lot of times I see a really common wrong answer, and that is a plus b cubed. Unfortunately, is not that easy. A plus b cubed multiplies into something a little bit more complex than that. Not too much more complex, but a little bit more complex. So that is not how it factors. But the first factor is simply just a plus b. The second thing that factors is actually a trinomial. So this factors into a binomial and a trinomial. So we start with a plus b, and then the trinomial is going to be a squared minus ab plus b squared. Now this part can be pretty hard to remember. So there's actually a nice little acronym to help us remember what that trinomial is. And that acronym is Scums. Now the U is lowercase because the U doesn't help us remember anything in that. But Scums is a lot easier to remember than SCUMS. So S stands for square the first. So what I do to get the first part of the trinomial is I square whatever that first part of the binomial was. C stands for change the sign. So I take this sign and I change it. The U is just to help us remember. M stands for multiply. So I multiply those first and last together to get the AB. And then the S stands for square the last. So I square the last term. Now another one that you guys may hear sometimes is SOAP. SOAP helps us to remember the signs, the positive, negative signs. So SOAP stands for same, opposite, always positive. So it's the same as the original, it's the opposite of the original, and the last one is always positive. Okay, but I like Scums better because it helps us remember what these values actually are as opposed to just the signs. So let's go ahead and do a difference of cubes. So I'm going to start with a minus b. Then to get the trinomial, I'm going to follow Scums. Square the first, change the sign, multiply, square the last. So square the first, change the sign, multiply, and square the last. And those are our formulas for sum and difference of cubes. Now, one thing I really kind of want to challenge you guys to do, actually learn these, actually remember this. I know it's going to be pretty easy if you have your notes in front of you and you're taking a quiz, but you're not going to have your notes in front of you in your future classes when you're going to need to be able to do this and need to be able to do this quickly. So again, know this formula. It's really going to be helpful for you guys down the long run. All right, if I have three terms, then how I work this out really depends on what those three terms look like. If A is 1, okay, these we talked about last class, those are the easy ones. We got to do these quick, okay? All we do is we just multiply what multiplies to the last and adds up to the middle. Those are our factors. We're done. If A is not equal to 1, we've got a little bit more work to do. So if you're really good with mental math, like I said, you can kind of try that guess and check method. If you're not comfortable with that, though, we're going to do what we did the longer way, which it's not really that long. Like I said, I like it because it always works. But we split the middle. Well, we start with A times C. Then we split the middle into our two new numbers. And then we do grouping. And that's kind of the process that we'll follow. And we'll do some examples of this here in a little bit. The last three-term one that may be a little bit faster is if you see a perfect square trinomial. And this one's going to be really important for difference of squares. So a perfect square trinomial, I didn't mean to erase that, is something in the form of ax squared. Well, let me just say a squared, make it a little easier. It could be plus or minus 2ab plus b squared. So this is the form of a perfect square trinomial. So really what it is, it's the square root of the first, the square root of the last, and then it's double in the middle. And plus or minus, it can be either because it depends, because a negative times a negative will still give you that positive. So really, if you guys remember, what this is what this turns into is something that factors into a plus or minus, basically the same sign, b squared. So remember, we talked about this a lot, I think in the first unit. If you have something in this form, how it's not just x squared plus 4 or x squared minus 4, it has that middle term. Okay, we talked about how you can do square, double, square in order to find what that is. So this perfect square trinomial, that's the result of that. It's the square, the double, and the square. The biggest thing with this perfect square trinomial to be careful of, sometimes it gets mistaken with the difference of cubes. Okay, notice that those are different things. What we're doing with the difference of squares, we're taking individual squared terms and turning them into their factors. Whereas a perfect square trinomial, the result is factored, and it can be either plus or minus. Okay, so a minus b squared is not a difference of squares. That's something that's already factored. So that part can get a little bit tricky. Perfect square trinomials really help us a lot for completing the square that we'll look at here in a little bit. Then the last one we're going to look at that may be new, that you may not have seen in Algebra 1, is four-term factoring. The reason that I like this AC split the middle grouping method is because with four-term factoring, you've already done that process already. So in order to factor four terms, we use grouping. All right, so now we're going to go through a ton of examples just to get the practice in. And one thing you'll notice today on your assignment's a little bit different. You were literally just doing the problems, the practice problems today. That is your assignment. Because really, guys, to get good at factoring, you have to do it. And you guys, you have to get good at factoring. I cannot stress that enough. Factoring is so important. This is a must know. Okay? Factoring is a must know. And like I said, it's not just a must know to kind of get an idea of what you're doing. It's you got to know it quickly and easily, and it's got to be something you can do well. So you've got to get the practice in, which is why, yes, it's a long assignment. You've got to do the whole thing, okay? Don't just find the answers. I'm giving you the answers, okay? Don't just write them down. Do it. Check your answers. Do the work. You guys have to get good at this process for your future classes. I don't make you guys do all those homework problems all the time. When I do, hopefully it makes you realize, guys, that it's important. Factoring is important. Okay, off the soapbox. Let's go ahead and continue. So this first one, two terms. There's no GCF. There's a minus in the middle, and I know the square root of both terms. So this is a difference of squares. So I take the square root of both terms. One is plus, one is minus, and I'm done. Like I said, difference of squares is one of the easiest things to factor. All right, the next one. Two terms, no GCF. I know the cube root of both of those terms. The cube root of x is x. The cube root of 125 is 5. So remember, when we're dealing with cubes, it's a binomial and a trinomial. The binomial is just the cube roots. The trinomial is where we use the Scums acronym. So I square the first, I change the sign, I multiply, and I square the last. And that's my final factored form. All right, going down to number 3. This is why you have to take GCF first. If you don't take the GCF first, you probably won't realize that you can factor this. Because I don't know the cube root of 54. I don't know the cube root of 2. but both of these numbers are divisible by 2. So I can factor out 2, which then leads me to something that is a difference of cubes. So again, difference of cubes, take those cube roots. Okay, well that's 3 minus x. Square the first, change the sign, multiply, square the last. And we're done. All right, now, next one, we're down to 3 terms, okay? So you can use any method you really want to factor this. We can go through the long AC, split the middle, and grouping. You can try kind of your guess and check method here to figure out what these numbers need to be. But this one actually, the fastest way to do it is to recognize this is a perfect square trinomial. The way I can recognize it, the square root of this is 3x. The square root of this is 2. If I multiply these together and double them, I get the middle term. That's how I know that it's a perfect square trinomial. So I do the square root of both of those. Whatever sign is here is the sign in between, and that's squared. So that is my perfect square trinomial. All right, so let's do some more. Again, if you feel comfortable with factoring, I would pause this and try and get as many of these done on your own as you can. But I'm going to go ahead and work all these with you guys together. All right, so this is one where, again, I'm going to go through the AC split the middle. I think it's a little bit faster, or a little bit easier if you're not good with the mental math to try and do the guess and check process. So what we do, again, A times C. So what multiplies to a negative 90 and adds to a positive 1? Well, those numbers are going to be 10 and negative 9. So what I do is I rewrite the problem, okay? I'm going to keep the coefficients the same. I'm going to keep the variables the same. So 6x squared, the numbers I just came up with were 10 and negative 1. So I'm making it 10xy minus xy. I have not changed those variables because I have not changed the problem. And my number was 9, not 1. Sorry about that. I haven't changed the problem. 10xy minus 9xy is still xy. I'm just rewriting it this way to make it easier to factor. All right, so now I'll look at these first two. What's common out of those first two is 2x. 2x comes out. That leaves me with 3x plus 5y. Now I go to the next two. Try to change color, sorry guys. Okay, whatever sign is here, I keep that sign. What's common out of those two terms is 3y. If I take out 3y, I'm left with 3x plus 5y. The parentheses match, so that's my first factor. Everything that's not in parentheses is my second factor. All right, going to the next one. So c plus d cubed minus 27. I do not need to multiply all this out, okay? I'm just trying to factor. I know the cube root of c plus d cubed. The cube root of c plus d cubed is c plus d. The cube root of 27 is 3. This is a difference of cubes, but that c plus d is kind of together. That's your a value. All right, so that's my binomial, even though it has 3 terms. Then I have the longer part. So I square the first, which is the c plus d. I change the sign, I multiply, and I square the last. Now, if you want to go ahead and FOIL that out, go ahead. For now, we're just trying to factor, so if you want to just leave it there for now, that's okay. It's not really going to simplify, but let me go ahead and show you guys what it'll look like, though, just to get that practice in on multiplying. C plus d squared, that'll be c squared plus 2cd plus d squared plus 3c plus 3d plus 9. All right, looking at the next one. This is a difference of squares because we know the square root of both of those terms. So the square root of x to the 4th is x squared. The square root of 16 is 4. So x squared minus 4 and x squared plus 4. Now, this is factored. It's not factored completely, though. And this is why it's really important to be comfortable finding those difference of squares. X squared minus 4 factors farther. X squared minus 4 is also a difference of squares. So that is then going to factor into x plus 2, x minus 2. X squared plus 4 does not factor any farther. So that's my solution. All right, going down to the next one. Again, we're going to keep these variables consistent, okay? We're going to look for what multiplies to a negative 24 and adds to a negative 5. Well, that's negative 8 and 3. So 2x to the 4th minus 8x squared plus 3x squared minus 12. Then we'll do our grouping. 2x squared comes out. 3 comes out. Parentheses match. And you're not done. Because again, be comfortable with difference of squares. X squared minus 4 factors into x plus 2, x minus 2. All right, so the next one, 4 terms. Like I said, if you've been using this method, 4-term factoring is incredibly easy because it's kind of like it gives you the first step. So we're going to follow that same process. Okay, we're going to do grouping. So I'm going to look at the first 2 terms. X cubed comes out. I'm left with x squared minus 4. There's nothing common here, so it's just minus 1. Parentheses match. X cubed minus 1 is left over. Now you'll probably notice we're not done. We're not even close to done because we have 2 different things we can factor. X squared minus 4 becomes x plus 2, x minus 2. And then x cubed minus 1 is a difference of cubes. So we'll use our difference of cubes. So it's x minus 1. And then Scums. Square of the first, change the sign, multiply, square the last. So square of the first, change the sign, multiply, square the last. All right, the last one is really pretty tricky because this one we are going to do grouping, but you'll notice if you try and do grouping like you're used to, it's not going to work out because you're not going to get anything common. So the way we're actually going to group this one is we're going to group these 3 terms together. And this is why it's really helpful to be familiar with that perfect square trinomial. This is a perfect square trinomial. This is x plus y squared. Well, now what I'm left with is a difference of squares because the square root of x plus y squared is x plus y. So I get x plus y minus z and x plus y plus z. And that one's probably the hardest one to see, but again, the more comfortable you are with recognizing some of these things, the easier it'll make it for you. All right, so now what we're going to do is we're going to switch and look a little bit more at some things to get us ready for completing the square. So we're going to find the value of p that is going to make these into a trinomial that would have a perfect square. So remember that perfect square trinomial has the form of a squared plus or minus 2ab plus b squared. So we want it to be in this form. So looking at the first one, it's a little bit easier. This is x squared. Okay, we need to figure out what this is, and we already know the middle. Okay, so 8x is our 2ab. And then x squared, well, that's a squared. Well, if the x squared is the a squared, then that means that x is a. So if x is a, then that means that 8a is equal to 2ab, which means that b is going to equal 4. All right, so if b is 4, in this format, b squared, 4 squared is going to be 16. So x squared plus 8x plus 16 is going to be your perfect square trinomial. Now, what you may remember, what we're about to talk about when we get to completing the square, if you know this value, okay, and this value is 1, then what you do is basically you divide it by 2 and you square it, but we'll get there. All right, so let's look at the next one. Again, we want this to be, we want to find what the middle number is, okay? Well, perfect square trinomials are in the form of a squared minus 2ab plus b squared. So in this form, a, okay, the a in this formula is 5a cubed. The b in this formula is 2b. Because again, if I take 2b and I square it, that would give me 4b squared. If I take 4a cubed and I square it, that would give me 25a to the 6th. Well, the middle term, okay, what we're actually solving for here, minus 2a b is going to then become negative 20 a cubed b. So again, if I had, well, sorry, I already have a negative on there, so just 20 a cubed b. So if I went back and rewrote the whole thing, okay, this would then factor into 5a cubed minus 2b squared. All right, so then on this next one, again, the format is going to be a squared minus 2ab plus b squared. Well, what I can tell from this, b is 7. And then negative 2ab is 70, well, negative 70x. So that means that negative 70x is going to be a negative 14a. Which means, again, what I'm trying to figure out is what's a. Well, if I divide, a is 5x. If a is 5x, the thing I'm looking for is a squared. So 25x squared is the missing value. All right, then on this last one, again, format, it's a squared minus 2ab plus b squared. So a here is 3x. Negative 2ab is equal to a negative 2x. My a is 3x, so I'm going to replace that. So negative 6x times b is equal to negative 2x. That means that b is going to be 1/3. So to find what my missing value here that I need, it's b squared, which is 1/9. So that perfect square trinomial would have a 1/9 there in order for it to be a perfect square trinomial. All right, so that's going to kind of, once we get to completing the square, it'll actually be a little bit easier. That part's a little bit trickier. We're going to look at the last few ways to solve quadratics. This first one, hopefully, is going to be probably the easiest method. And what that is instead of going through quadratic formula or factoring or anything else, we're just going to solve using square roots. We're going to solve this using the same properties we would do just to get x by itself in a normal case. So if I want to get x squared by itself here, the first thing I'm going to do is I'm going to multiply both sides by 2/3. So that would give me x squared equals 18/24, which simplifies to 3/4. To get x by itself, I would square root both sides. And the biggest thing to remember here, the biggest mistake, whenever you take a square root, the answer is both plus or minus. Because a negative square root squared will give us 3/4, and the positive square root squared will also give us 3/4. Now, whenever you square root a fraction, you square root the top and the bottom. So this becomes the square root of 3/2. All right, looking at the next one. So this one also can be done pretty simple. What I'm going to do is I'm going to try and get this x by itself, and I'm going to follow basically the same kind of pattern that I would do if I was solving this equation. So if pretend the squared wasn't there, the process that you would do to solve for this x, just don't distribute, I guess, because it's squared. But that's how we're going to solve this. So the first thing I'm going to do is I'm going to add 4 to both sides. All right, to get those parentheses by itself, I'm going to divide by 29. Now that those parentheses are by itself, I can square root both sides. Remember, when you square root, it's going to be both positive and negative. And square rooting that fraction, you square root the top and the bottom. Then one last step, just add 3. And then you can actually do that math. Those are actually rational numbers. So we can actually do 3 plus 7/5. And we can actually do 3 minus 7/5 to get my 2 answers. So if you only have an x that's squared and you don't have kind of that other variable in there, that's probably the easiest way to solve those equations. Now we'll use this process within completing the square. So the first thing that you can use completing the square for that's really helpful is to get a quadratic in vertex form. So we looked at those two formats last class, the kind of standard form and vertex form. Currently, these are in standard forms. So if I want to get this in vertex form, I can using completing the square. So what I do is I'm going to start by seeing, hey, is there anything in front of this x squared? And if there is, I'm going to factor it out. In this case, there's not, so we're fine. So now what I'm going to do is I'm going to go ahead and just rewrite this. So I'm going to do x squared plus 4x plus, and I'm going to leave a blank, plus 10. And then I'm also going to do minus a blank, because I can't change this equation anyway. If I add something to this, I also need to subtract something from it. To figure out that number that goes in the blank, what we do is we take the b value, we divide it by 2, and we square it. So 4 divided by 2 squared is 4. If I add 4 to this equation, I also have to subtract 4 from this equation. Well, now, x squared plus 4x plus 4 is a perfect square trinomial. So that factors into x plus 2 squared. 10 minus 4 is just 6. And now this equation is in vertex form. All right, so now let's go ahead and look at the next one. Same idea, but we have an extra step. What I need to do is factor out that 3. And I'm still going to include my blank. I'll leave that plus 40 out here, because that's going to affect kind of that y-coordinate of the vertex. And I'll figure out what goes in that blank. So the number that goes in that blank, b value divided by 2 squared. So 4 divided by 2 squared is, again, 4. The problem, though, is I haven't added 4 to this equation. I've really added 3 times 4 to this equation. So instead of adding 12, I actually need to subtract, or adding 4, I'm actually adding 12. So I need to subtract 12. So now, this still factors into a perfect square trinomial, and then 40 minus 12 is going to leave me with 28. So that's how I can use completing the square to get this into vertex form. You also can use completing the square to solve equations. Now, this, I think, is a faster method than quadratic formula when a is 1 and b is even. Now, if a is not 1 and b is not even, it's kind of a toss-up on which one's faster, but I do think this is by far the fastest method for these types of questions. So what we'll do here, a little bit different, but same kind of process. So I'm going to do x squared plus 8x plus blank again. But this time, I'm going to take this number, since I'm not getting it in vertex form, and I'm going to be eventually solving this, I'm going to move that c value to the other side. What's also different when I'm solving is I'm not going to subtract a blank, because again, I'm trying to keep this equation the same. If I add something to the left side of an equation, in order to keep it balanced, I add the same number to the right side of the equation. So whatever I add to the left, I'm going to add to the right. Well, in this case, again, same process, b divided by 2 squared. 8 divided by 2 is 4, 4 squared is 16. This factors into a perfect square trinomial. It's x plus 4 squared. This becomes 20. And now we're going to solve. And now this is going to kind of follow that same process we did when we were solving those square root equations, or solving those questions by taking square roots, an example or two before this. So square root both sides. Remember, it's plus or minus. That square root can simplify, and then just subtract that -4, and you have your answer. So again, when a is 1 and b is even, I do think that this is a faster method for solving these quadratics. Now, when a is not 1, we kind of have some extra steps here. So what's a little bit different here, and actually a little bit nicer when we're solving, what I don't need to do is factor out the 3, because we have an equation now, and not this graph that we're trying to rewrite. So since it's an equation that's equal to 0, I can just divide everything by that number that's out in front. So I'm going to divide everything by 3. And then I'm going to rewrite it, so I'll do x squared plus 3x plus blank equals 5/3 plus blank. To figure out the number that goes in the blank, take b, divide it by 2, and square it. So 3 divided by 2 squared is going to be 9/4. All right, this is going to factor into x minus 3/2 x plus 3 over 2 squared. And in case you haven't noticed, this is always half of this whenever you factor it. It's because of that 2ab formula. Add those two fractions together with a common denominator. That's going to be not very pretty, 47 over 12. All right, square root both sides. Remember the plus or minus. Move that 3 over 2 over. And then really at this point, it's just kind of cleaning up this little square root fraction based on what you guys have done before. So one thing that we can do is we can simplify square root of 12 into 2 root 3. And then we also can rationalize the denominator by multiplying the top and bottom by root 3. Now, rationalizing the denominator is one of those things you may not need to do in all of your classes, but it's still a good thing to learn because a lot of times you won't see multiple choice answers unless they're rationalized. So that's 2 times 3, which is 6. All right, so the last thing that we're going to do here is we're going to look at something called the discriminant. So you may have talked about this in Algebra 1. The discriminant is part of the quadratic formula. Specifically, it's the part of the quadratic formula that's under the square root. What it does is it helps give us information about our solutions. So if that discriminant is a negative number, that tells us there will be no real solutions. Now, we'll deal with what kind of solutions we have next class, but for now, there's no real solutions if that's negative. If that discriminant is 0, there's going to be one real solution. And if that discriminant is positive, then there'll be 2 real solutions. So on this equation, what we're going to do is we'll just use the discriminant. So we're just going to use b squared minus 4ac and see what kind of number we have. So that's 9 minus 16, which is a negative number. Since that's a negative number, that means that this has no real solutions. It also means that that graph will not cross the x-axis because there's no real solutions. All right, let's look at this one. B squared minus 4ac. Well, that's going to give me 0. That means there's one real solution. That also means this graph will only touch the x-axis in one place. That means the vertex is on the x-axis. All right, so that is all of your quadratic review and potential new quadratic information. So really these first 2 days combined is a little ton of Algebra 1 review and a few new things, and that's what your next quiz is really going to cover. A lot of really essential skills that are really going to come up not only in your future classes, but also throughout this class as well. So they're really important for you guys to have as a foundation. That's why you guys have to do all those practice problems, because again, you got to really get that foundation down for these skills for future classes and units.